Right now, physics is operating with a torn map. On one side, general relativity describes gravity through smoothly bending cosmic grids. On the other, the Standard Model tracks hyperkinetic, chaotic quantum particles. These two halves of the map simply do not stitch together. For decades, researchers have hunted for a grand unified theory by smashing matter into smaller and smaller pieces. This search assumes that the answer to unification is a physical object, a final, tiny particle that explains everything. The A framework refocuses the search on the way we define force. It moves away from the idea of forces as independent things and instead treats them as emergent behaviors of a single system. Imagine looking at an ocean. You see steady currents, swirling whirlpools, and crashing waves. They appear to be distinct entities, but they are all just different ways a single medium, water, moves and interacts with itself. To find a true unification, we have to look past the individual names of the forces and understand the underlying mechanics that allow a single field to take on these different physical shapes. At the base of this model is the A field, a continuous, fundamental substrate of vibration filling the universe. The first rule of this field is phase coherence. This is the moment when multiple, random background vibrations align and synchronize their timing, allowing them to act as a single, coordinated structure. When this synchronization is concentrated in one area and tapers off in another, it creates a coherence gradient. This 3D surface plot maps that gradient. The yellow peak represents maximum coupling intensity, where phase is tightly synchronized. Moving away, synchronization drops off, creating sloping purple edges. This spatial variation of coherence warps the field's geometry. We experience this warp as gravity. It's the field's geometry adapting to internal gradients of coherence, without the need for a separate graviton particle to carry the message. While gradients describe the large-scale slopes of the field, the internal phase also exhibits an active, circulating motion. When the phase of the field begins to curl and circulate upon itself, it creates a series of U1-style rotational loops. This specific rotational interaction generates electromagnetism. The familiar push and pull of magnets and the behavior of light emerge directly from this phase curl. But the field can also reach a state of extreme complexity, the reality knot. In a reality knot, the field's phase becomes braided and folded over itself. The structure becomes topologically locked, preventing energy from leaking out. Because this energy is confined and cannot be untied, it creates an unbreakable, high-intensity binding force. This topological confinement provides the exact stability and scale required for the strong nuclear force to hold an atomic nucleus together. Through this structural logic, these forces are simple geometric states. They are the gradients, the rapid rotations, and knots of one underlying phase. We are moving away from a model of the universe as a void filled with isolated particles and force messengers. In its place, the E model offers a single, interconnected, and highly organized vibrational manifold. This image illustrates how these forces act as optimization mechanisms. On the left, high-entropy cosmic dust is scattered and complex. On the right, it has been compressed into a singular, low-entropy planet. The field organizes matter to minimize its own informational complexity. This shift suggests that grand unification isn't hidden in the subatomic world. It is achieved by recognizing the large-scale geometric structure of space itself. A moment of wonder. Matter, gravity, and light emerge as the distinct geometric verses of the exact same cosmic song.